you are doing question number 9 from exercise 13.5. It's also from exercise vector chapter, and it is given here P and Q are such that P 11i minus 24jq is given that information. Find the value of each of the constant alpha and beta such that is the information provided here. Oh, extremely sorry, it went wrong. So two values are there, 2p plus this. So this is a vector equation. We are going to use on the both side that one, which is p plus twice p. P is given 11i minus 24j, and then twice q. 2q means 2 into 2i plus lambda j, and on the right side the value is given alpha plus beta I minus 20j. So you can say this is a vector equation. Property of the vector equation is we can equate the vector from the both side. I think I coefficient of I equals to I, coefficient of j equals to z. This is the rule. So on the right side coefficients are actually in order, but on the left side it is not. Let we arrange it according to I and j. 4 to the 4i plus 11i, which is 15i, 4 plus 11, then minus 24j and 2 alpha j. So if we take j common, then we can write it 2 alpha then minus 24, because coefficient of j is also, and on the right side is written here alpha plus beta I minus 20j. According to the rule of vector equation, we can equate from both sides coefficient of I. If we take coefficient of I from the both sides, it will be alpha plus beta equals to 15. This is equation number 1. And if we took the coefficient of j from the both sides, then it should be 2 alpha minus 24 equals to minus 20. So we can write it 2 alpha equals to 24 minus 20, it is 4. So alpha equals to 2. We got the value of alpha, which is 2. Now we're going to put it here to get the value of b in equation number 1, which is 15 minus alpha, which we can write 15 minus 2, and we got from there value of beta is 3. Hope it is clear. Then the second question, it is written here using the alpha and beta in part 1 unit vector in the direction of p plus twice q. We did some of the unit vector in previous questions. Similar method we are going to apply here. For unit vector we have to find out the vector first, p plus twice q, which is written here, and p is 11i minus 24j plus 2q, which is 59 minus 24j, and if we put here the 2q, 2 into value of twice I plus alpha, we got 2, we can write here twice I plus twice j. Now finally you can write here 11 plus 4 is 15i, then minus 24 plus 4, which is minus 20j. Okay, 59 minus 20j. This is our p plus twice q. So if we want the unit vector, we have to divide with the modulus of this vector. Unit vector you can write here unit vector, which is 15i minus 20j divided by modulus of this vector, which is 15 square plus, don't keep minus sign inside or outside of the bracket, always it would be, even both of the vectors are given is a negative sign, it's not a matter, but inside always there is a positive sign, because we are going to apply here the formula of the Pythagoras. So that two vector actually it is coming out. Let me use calculator to do that, which is root over 15 square plus 20 square, and it gives us value 25. Let me write it 25. Now in the smallest fraction, if I am going to write 15i by 25, another one is minus 20z by 25. So finally we got from here, if I cut with the 5, then 3i by 5 minus, if I cut with the 5, then this is 4z by 5. That is our answer of the second part. Now we are moving to the question of the next question, which is written here. For vector diagram we have to use right now for the B part of this question. Here is the B part. Question asking us to find out the OC in terms of AB and lambda. That is a different question, not there is no similarity with the previous question. This is the question OC. So we can reach here OC by writing here, say OC equals to OA plus AC. OA plus AC. OA is A given, and AC, this is the relation AB is to AC, which is 1 is to lambda. AB part is lambda. So if I wanted to define AC by AB, we need it AC by AB. AC part is lambda and AB part is 1. So AC we can write here lambda of AB. Let me use this information here. AC equals to lambda of AB. Then our AB is lambda, which is OB minus OA. So it is A plus lambda B minus A. Now finally you can write it by taking a common, which is 1 minus lambda, then plus lambda B. And this is our answer in terms of AB and lambda for question number B, OC. That is our answer. Different question. And the next one is also different. S and T have position vectors S and T with the respective origin, and OST do not lie in a straight line. It's okay, given that the vector 2s plus ut is parallel to the vector this. So two vectors are given in terms of S and T, and constants are given as well. Find the value of mu. So in that case we can use one thing. I'm going to write it on the left side with a different color. C is here. If there is a relation given 2s plus mu t parallel, one vector is parallel to another vector, which is mu plus 3. I'm going to write mu plus 3, then S is a vector here, plus 9t. If written here parallel, then only the relation is coefficient of vectors are equal. Say coefficient of S is here 2 from the left side, and coefficient of S from the right side, which is mu plus 3, we are going to write. So this is the coefficient of S, which is equal to coefficient of T as well. On the first vector, coefficient of T is mu given, and the second vector coefficient of T is given 9. This is the relation. If two vectors are there parallel written, then their particular vectors ratios are equal from the both sides. This is the main relation. So now we are going to solve this equation. Then we would get from here mu. We needed to multiply, cross multiply, which gives us mu square plus 3 mu, and 9 to the 18, so we can write here minus 18 equals to 0. We have to solve it by doing the middle term break. I think 6 mu minus 3 mu minus 18 equals to 0. So if I take mu common, which is mu plus 6, another minus 3 common, then it is mu plus 6 again equals to 0. So we got two values of mu. One is negative 6, another one positive 3. But in our question it is written here mu is a positive constant, so we need to ignore the negative one. mu equals to minus 6 is not applicable. We are going to write it this value, so we can cancel this one, we're not taking. So our answer is mu equals to 3, and this is our only answer in that case.